In the previous video, we have talked about deployment, services, ingress, pods, whatever. So they make sense if we talk about them individually. But let's imagine we are deploying a real application, not a demo, not a Nginx container. Suddenly we need deployment, service, ingress, config map, secret, horizontal pod autoscaler, persistent volume claim, service account, role binding for one application. Now imagine doing the same for dev, staging, for your production. Now imagine 10 microservices. That's when Kubernetes start to feel a lot heavier. Not because Kubernetes is bad, but because we are managing dozens or hundreds of YAML files. This is where Helm comes in. Helm is simply the tool that helps us packaging, configuring, installing, upgrading, and managing the Kubernetes. Think of it as the packet manager for the Kubernetes, just like npm for JavaScript packages, pip for the Python packages. Just like that, we have Helm for the Kubernetes. Let's talk a little bit about the history. When Kubernetes started to become popular, people started building increasingly complex applications. Installing software often meant installing multiple kubectl files, YAML files. Kubernetes community needed something really good to manage all those YAML files. Helm was created to solve that problem. Today, it has become one of the most important and necessary tools in Kubernetes ecosystem. Let's make it concrete. Suppose I want to install Grafana. Without Helm, I might need deployment.yml file, service.yml file, secret, config map, volume, ingress, and I need to understand each of them individually. With Helm, you can just do Helm install Grafana from Grafana/Grafana. Helm takes care of creating all those resources. You can think of Helm as application combined with configuration, versioning, and deployment logic, all packaged together. The most important concept in Helm is chart. A chart is simply a package. For example, in Grafana chart, there are 3 files. One is chart.yml file, values.yml file, and inside there are templates. Let's understand this. Chart.yml file. It contains the metadata, like name, version. Think of it like a package information. And inside the template, it contains the manifest of service, config map, deployments, but they are not the normal YAML. They are just templates. And here comes the hero of our Helm, that is values.yml file. It contains all the configurable variables like replica count, image information. This file customizes the application. Let's see the problem Helm solves. Without Helm, in development we need 1 replica. In production we need 10 replica. Many teams create the duplicate YAML file for the production and for the dev. And the Helm says, why duplicate? Create one template where the replicas has the values.replica count, then define the values for the deployment. Replica count is 1 and production replica count is 10. Same deployment, different configuration, one source of truth. When you run Helm install my app, Helm performs 3 steps. First step is it reads the chart. Second step, it renders the templates. And third step, it sends the generated YAML to Kubernetes. Helm doesn't run container, Kubernetes does. Helm just helps to manage the resources. There are some really important Helm commands. The first one is Helm install and your application name. That just deploy the application. Next is Helm list. It just shows the installed applications. Third one is Helm upgrade my app. That just change the apply. Helm uninstall my app. That remove the installed application. One of my favorite command is Helm template. It generates Kubernetes YAML without deploying it. There are also commands for validation, Helm linked dot, and there are also commands to see the history, Helm history, and Helm rollback. This can save you during the production incident. Imagine now you want the monitoring. Without Helm, you clone the repositories, edit the YAML files, apply dozens of manifests, debug failures. With Helm, you can simply do Helm repo add Prometheus community, Helm install monitoring. A few minutes later, you have Prometheus, Grafana, and the alert manager running in your cluster. This is why Helm became popular. It transformed Kubernetes software into installable packages. Today, Helm is used everywhere. You will see it being used for Argo CD, Flux, Git operations, platform engineering, internal developer platforms. A typical modern workflow looks like Git, your Helm chart, and Argo CD and deploy to Kubernetes. You only need to change values file, that might be values-dev, values-prod, and the manifest remains the same. And Helm helps to create the resources using that value file and manifest file. So using one single values-dev file and values-prod file, you can create multiple manifests, multiple resources depending upon the stages. And then Argo CD helps to deploy them and Kubernetes helps to run them. If Kubernetes gives us a building block, maybe deployment, ingress, services, the Helm gives us the way to manage them, manage those resources. Instead of managing hundreds of YAML files manually, we package everything into a chart, configure it with the values, and deploy it with a single command. That's why Helm became one of the most important tools in the Kubernetes ecosystem. That's all for this video. I hope you have understood about the Helm and how to use it in the Kubernetes to manage the resources. Thanks for watching till the end. I will see you in the next video. Bye-bye.